Okay, in this video I have a pentagon. They give me the area and I want to find the length of one of its sides. Remember, it's a pentagon, so all the sides are the same. Now we've very few tools, I suppose, or methods to find aspects of pentagons, such as areas and lengths and things like that. So for that reason I'm going to divide this into triangles. And all the triangles are going to be the same. And all those angles in the middle will add up to 360. And there's 5 of those vertices here. So if I divide 360 by 5, I will get 72 degrees. Okay, now I'm going to concentrate on one triangle. Oh, there it is. And I'm going to just label the size of that triangle, or sorry, the vertices. So that would be 72 degrees. Now remember, it's an equilateral triangle, which means these 2 degrees will be the same. So 180 minus 72 is 108, and then divide that by 2, which is 54 degrees. And remember, I'm looking for that side. Now here's what I'm thinking. I know I could find the area of this triangle very easily. Okay? The area of the whole lot, or 5 of them, is 600. So the area of one of them is 600 divided by 5, which is 120 centimeters squared. Now if I could just get the height of that, I could use my half base by height formula to work back and see what this height actually is. So I'm going to call that height y. Let's see if I can find it. Remember, in right angle triangles I have many tools to work with, okay, like Pythagoras' theorem, SOHCAHTOA, things like that. So I am going to take that triangle, but I'm just going to concentrate on half of it. So we'll take the triangle again. This time I'm just going to half it. I'm going to call that y. That's what I'm looking for, that height. I'll label what I have. This is 54 degrees. This whole length here is x. If I just concentrate on this bit though, I'll call it x over 2. There's a right angle. And this here, well, the whole lot of that will be 72. So this here is 36 degrees. Right, I want to find y. If I label my sides, so there's O in relation to this angle, there's H and there's A. Can I find y? Well, I want y, I have A. So I'm dealing with trigonometric ratios first. So could a hungry, stupid ostrich have taken over America? And we see that tan deals with O and A. So the tan of 54 degrees equals y over x over 2. The tan of 54 is 1.38 equal to y over x over 2. I want to know what y is, so if I divide this side by x over, multiply this side by x over 2, multiply by x over 2, get rid of the x over 2, I multiply this side by x over 2, I'll have 1.38 multiplied by x over 2. So the height of my triangle is that. Okay. Now I'm going to concentrate on my area. So remember, area of a triangle, area equals half the base multiplied by the perpendicular height. Okay, well I know what the area is, it's 120. Half the base is x, and the perpendicular height is this. So 1.38 multiplied by x over 2. Okay. And now we're just going to do a bit of algebra to see if we can find out what the x is. Okay. So I want to get rid of the half and multiply by 2. Multiply by 2 on this side, I get 240 equals x multiplied by 1.38 x over 2. Multiply by 2 again, I'll get rid of this 2. So multiply by 2 again, I'll have x multiplied by 1.38 multiplied by x, and that equals 480. Just to type that up, 480 equals 1.38 multiplied by an x by x is x. squared. If I divide this side by 1.38, I have to divide the other side by 1.38. I get 347.82, and that equals x squared. Just need to get the square root then of both sides, find out what x is. So square root of this is x, and square root of that is 18.64. So 18.64, it's centimetres because we're talking about centimetres squared. So that there is 18.64. Okay. And the reason I know centimetres is because we were told it's centimetres squared at the start. Okay, so that's that, guys. Thanks.